Hello everyone, in this video I'm going to be finding for the second derivative at x is equal to 4 and y is equal to negative 3, and I'm also going to figure out if there is I'm also going to figure out if it's concave up or down near this point. And we're also going to be using these parametric equations. Xt is equal to t squared and yt is equal to 2 times t plus 1. In my last video, it was about parametric equations, and this video kind of leads to this video. So in my last video, we found that t is equal to negative 2 and dy divided by dx is equal to 1 divided by t. So if you don't know why this is, then you should go look at my last video. Okay, now to solve for the second derivative, d squared times y divided by dx squared, we're going to, factor this so that we would have d divided by dx times dy divided by dx. I hope you can see why these two are equal to each other. D times d makes d squared times y, so times y divided by we have two dx's, so that's why we have squared. And this is equal to, just like I said before, in my last video, we found for the dy divided by dx using these parametric equations, and we got 1 divided by t. And also, what does d divided by dx mean? Well, it basically means we're taking derivative of something, right, in terms of x. But since we have 1 divided by t in terms of t, we can't take derivative of it in terms of x. So, we would have to change it like this so that we would be able to take derivative of it in terms of t. But since we changed the x to t, we would have to multiply everything by dt divided by dx. Because then these two will cancel out and dx will go here, so these two are technically the same. I'm going to work down here now. If we take derivative of 1 divided by t, we have negative 1 divided by t squared multiplied by dt divided by dx, which is equal to 1 divided by 1 divided by dx divided by dt. To find for dx divided by dt, we just have to take derivative of dx, which is equal to t squared. And so that would give us dx divided by dt as 2 times t. And so we're just going to replace this by, dx over dt by 2t. Multiply these two together and we have negative 1 divided by 2 times t to the power of 3. And in my last video, again, we found out that t is equal to negative 2 when x is equal to 4 and y is equal to negative 3 in this for this parametric equation. So I'll just put that in. And if we put in t is equal to negative 2 here, we would have 1 divided by 16. And now we found for the second derivative at this point, which means that now we have to determine whether it's concave up or down near this point. If you don't know already, to figure out if it's concave up or down, well, this is how I memorize it. So this is concave up and this is concave down. And this is like a smiley face, right? So f prime prime has to be positive. And if it's concave down, then it's feeling bad, so it's less than 0. And since we got the second derivative as 1 divided by 16, which is larger than 0, that means that it's concave up. And so that would be, there would be concave up near this point. Thank you for watching, everyone. In this video, I determined whether there's concave up or down when x is equal to 4 and y is equal to -3 for this parametric equation, and also found for the second derivative, of course. Thank you for watching. Bye.